Hello and welcome to the Evidence Based Chiropractor. I am your host, Dr. Jeff Langmaid. Today we are talking all about the dorsal root ganglion. This is an unbelievably important structure in and around the motor segment unit. We're going to break down what happens when there's compression on the DRG and also what can potentially happen when pressure is taken off the DRG. That and much more on today's episode. We're going to talk about a paper published in Spine, and it is titled The Vascular Pattern of the Human Dorsal Root Ganglion and Its Probable Bearing on a Compartment Syndrome. This paper it's pretty geeky. I mean, it gets out there in some complex terms, but we're going to try to break it down in a way that is actionable for you and in your practice, the communications that you have with your patients, and also how you think about your treatment and care, because dorsal root ganglion is super important. And let's pick it up right there. What is a dorsal root ganglion? Dorsal root ganglion, also known as posterior root ganglion, is a cluster of neurons, which by definition is a ganglion, in the dorsal root of the spinal nerve. The cell bodies of the sensory neurons are known as first-order neurons, and they are located in the dorsal root ganglion. So the axons of the DRG are afferents. And in the peripheral nervous system, afferents are the axons that relay sensory information into the central nervous system, aka the brain and the spinal cord. So very, very important structure. If we just take it right from there, what is a dorsal root ganglion? It is a cluster of neurons that transmit sensory information into the brain and the spinal cord. Very important, right? Sensory information is how we perceive what's going on in space. It's how ultimately we could perceive potentially noxious stimuli, aka what we respond to as pain. Very, very important. As a matter of fact, researchers have cited the DRG essentially as being the quote-unquote brain of the motor segment unit. It is literally that important. So it's a crucial structure. It's a crucial structure in how our bodies transmit information. Again, the cluster of neurons transmitting afferent or sensory information into the central nervous system. It's also very important because of where it sits in and around the spine. So it sits kind of right at or external to that neuroforaminal canal. So it has the opportunity and or ability, so to speak, to have compression placed upon it. That compression can be caused by a variety of things. Could be a disc, could be a facet. We'll talk about that in a moment. But that can have negative implications. Also, decompressing that DRG could have potentially very positive implications. So we're going to break that down and much more on today's episode. And let's start right there with some of the key points that the researchers were attempting to go through and answer with this study. So number one, they asked themselves the question, is there a basic pattern of vascularization that's common to all dorsal root ganglions? In other words, can we look throughout the spine and see that the DRGs and the vascularization of them is pretty standard throughout the whole spine, or does it vary wildly depending upon the body region? And what they found is it can be considered, there is a basic pattern of vascularization. This is important because that means we can apply what we learn in one body region, such as a lumbosacral spine, to other areas of the spine pretty easily. So that's a great thing. Secondly, they found pressure on or within the ganglion may produce a venostasis in the periganglionic venous plexus that can lead to a compartment syndrome. So compression can cause venostasis, and that can cause a compartment syndrome. That is not ideal, and that's what we're going to break down in supreme detail as we go through today's episode. And finally, because of the possible vascular reaction, pressure on the DRG should be relieved and or avoided. Well, yeah, if it's causing a compartment syndrome and causing negative implications, probably a pretty good idea to remove that pressure or avoid it when we can. So important things to keep in mind as we go through all of the data and all of the literature in this study. And we're going to hop in the Wayback Machine here and set the stage for where they're at with today's literature. So this research paper started out by citing a paper that was published in 1934. If any listeners were born before then, shoot me an email, Jeff at the Evidence Based Chiropractor. I'd love to know. But it's called A Classic Report by Mixter and Barr. And the consensus prevailed that acute encroachments on the lumbosacral nerve roots are responsible for most back pain and sciatica. So, hey, if there is a pinch, if there's an encroachment on a nerve root, that it can be a major reason for back pain and sciatica. We know that to be true today. You have foraminal stenosis, lateral recess stenosis, pinched nerve, foraminal encroachment, however you want to define that. Well, that came out in a classic report in 1934. So that was the start of identifying that compressions may be a challenge. But we're talking strictly about the nerve roots at that point in time. As early as 1948, another paper came out that postulated compression of the DRG by the dorsal lateral disc protrusions and or hypertrophy of the facet joint might also be implicated. So if you have a lateral disc protrusion or a hypertrophic facet joint, that could be causing a problem. That's where they took that information, and that's as the literature evolved, that's where they went. And it was not until 1977 that a paper published basically a physiologically based approach showing that although chronically injured nerve roots are sensitive to compression, acute pressure on normal dorsal roots failed to elicit the expected nerve activity. But by contrast, prolonged periods of repetitive nerve firings followed a minimal acute compression of the normal DRG. So this was sort of the start of learning about, okay, again, was trace it back to 1934. Pressure, compression on nerve roots probably is a big source of back pain and sciatica. Then as we get into the late 40s, early 50s, they start talking about the dorsal root ganglion itself and the potential for a disc or a facet to cause challenges with that. And then in the late 70s, it comes to more of a, neuronal thought process where, repetitive nerve firings, and compression might be going hand in hand, and that might be causing the challenge. So the logical question becomes, well, what do we consider a compression? How much pressure does it take to form a compression? And ultimately, they answer that question. By using hydrogen clearance method, they were able to show that the dorsal root ganglion blood flow was reduced by up to 45% by a compression of 60 grams on the distal side of the ganglion and 10 to 15% by equivalent pressure on the proximal side. So 60 grams of pressure could cause up to a 45% decrease in the dorsal root ganglion blood flow. So that's pretty significant. Just 60 grams of pressure, almost cutting the blood supply in half. That becomes pretty substantial. So let's take that one step farther. The researchers found, quote, the demonstrable fact that when a mechanical pressure is applied to an endoneurial vascular system, a venostasis is achieved at a significantly lower pressure than required to stop the arterial flow. So that's an important piece of the puzzle, that the venostasis occurs first. Very light pressure can cause venostasis or backup in the veins, so to speak, but the arterial flow can remain for a significant portion of time. So they also cite, nerve constrictions of a lumbar stenosis may produce a point of complete blockage of the radicular veins while sparing their radicular arteries. Thus, as indicated in the publication by Park, this greater challenge on the efferent side of the radiculomedullary circulation may be more responsible for ischemic neuropathies than was previously supposed. So they're basically saying this is quite often more of a venous issue than an arterial issue. Very light pressures cause venostasis, but it takes a heck of a lot of pressure to cause an artery to block off. So this is where we start to get in more and more to, what's the total effect and how does this work? And I'm going to read directly from their paper, really the conclusion of their findings. They found, quote, the total effect of an external mechanical compression is complex. In an acute phase, the compression would force the dural capsule to directly impede the immediately underlying efferent flow in the periganglionic plexus and thus resist the normal afferent nutrition to the deeper parenchymal constituents. By subsequent alterations in the vascular permeability, a resulting endoneurial edema would then reflexively push the periganglionic venous plexus against its unyielding fibrous container and create a more chronic venostasis. Very, very important there. So there are stages to what occurs when there's a compartment syndrome or a compression. Stage 1 is very light pressure can directly inhibit the venous flow, and that's going to back up, so to speak, cause venostasis, a backup in the veins around the area. And then over time, Additional compression can actually place the DRG up against, there's only so much space in the body. So if it places it up against a structure, whether that's the fibrous structure of it itself, whether that's a facet joint, whether that's a disc, as postulated decades ago, that can cause compounding issues. So it goes without saying that when we can take the pressure off a DRG that has venostasis, we are going to enable better nutrient transmission and better function in that area. As we talked about at the top of this episode, that DRG is cited as the brain of that motion segment unit. So the brain needs to make sure that we have good arterial flow and good vascularization without compromise. So important thing to keep in mind from maybe an indirect practical application, you're not going to maybe necessarily be able to impact the DRG with a specific adjustment or a specific stretch or exercise. But understanding the fact that the DRG can have compartment syndrome due to a venostasis, and the fact that inflammation and or compression around that area is a challenge goes to show that if we can do things to take the pressure off, reduce the inflammation, that can reduce the venostasis, it can improve the overall blood flow in the area, which should go back to improved function. Taking it full circle, we know the DRG is a ganglion, a cluster of neurons that is directly responsible for afferent or sensory information being passed into the brain or in the spinal cord. If the blood flow around that area is backed up, if there's venostasis, it's very likely to cause a functional issue. If we're able to take the pressure off there by reducing inflammation, by improving the motion in the area, etc., it is going to set the person up for success as we go through our care and treatment plan. So there is a lot into this study. This study got really heady in terms of the technical aspects of it, but I think it's important to understand what's going on in and around the spine, and ultimately start the conversation on how is what we do with our chiropractic care able to impact that in a positive way. Taking pressure off of DRG sounds like a good thing to me, and keep that in mind as you go through and examine your patients, as you speak with your patients, and as you deliver your care this week in practice. If you have any questions, feel free to hit me up, jeff@theevidencebasedchiropractor.com. If you have not left any ratings or reviews on iTunes and you're listening to this on your phone, you can do that directly from your phone right now. We love to receive feedback, and it is always good. That helps more chiropractors find out about this podcast. So please leave us a rating or review if you have the opportunity on iTunes. Again, shoot me any questions or comments at jeff@theevidencebasedchiropractor.com, and I look forward to talking to you very soon. Have a fantastic week in practice, and I'll talk to you soon.
Thank you for joining us on this episode of the Evidence Based Chiropractor. If you want to grow your practice, come back for next week's episode. If you want to grow faster, visit theevidencebasedchiropractor.com and join our MD Marketing membership today.